It's my honor here today to take part in the MariaDB Server Fest online conference. Before we talk about our topic, first let me introduce myself. I'm the product manager of a Tencent Cloud database team, and I once was a developer and for 7 years, and then I became a product manager for 5 years. So I've done this job for 12 years. Today we're going to talk about how to help financial users to use Tencent Cloud MariaDB. I think we there have 3 aspects to talk about. First is why we choose MariaDB, and I think this problem maybe can stem from why we choose it before we start up Tencent Cloud. Before we provide the database on the cloud, we actually use MariaDB for our account information, and then we provided the database to our customers in Tencent Cloud, and they have some requirements. We will talk about what we do to satisfy their requirements, and meanwhile, how to enhance MariaDB. Okay. Why we choose MariaDB? I think there are nearly 4 reasons why we choose MariaDB. First one is new features, not just MariaDB 10.5, 10.4, but at the very beginning, MariaDB have some features that MySQL don't have it, or they have it, but just in the enterprise version, such as the thread pool and some grammar, or in the latest version, we have S3 compatibility, but MySQL don't have it. Maybe it will have it later or never. Another one, MySQL don't have some engines that we have it in MariaDB, such as MyWorks or Column Store, and some other engines such as Cassandra. So we like it. Use MariaDB for some new features and some engines that will never happen in MySQL. And some other reason, maybe it's not some technical reason, but it's also very important. And sometimes that will make users to choose which one will be their best choice. First is the license. MySQL, there's some of their drivers under LGPL, and MySQL is under a commercial database company. Maybe there has some potential risk for us. So I think every user and every cloud provider have to consider it. And another one is open. Me and my colleagues have participated in several MariaDB conference. We've seen the decisions can be reviewed and debated, and we can talk about what we're going to do in the next version, and we can talk it with the developer, with Monty, so we like it. Okay, the last one. But we put the database on our public cloud and private cloud. We have more and more users, and especially the financial users. They have a lot of requirements, such as security. We have users from bank, from insurance company, from securities company, and they care so much about the security, not just themselves, but their supervision organization, some bureau, or some other organization from their industry, and they have a lot of data, and the data will accumulate from year to year, and we need to scale out the data, and we need to update the database without interruption. And they usually have one active node and two standby nodes, and also have some disaster recovery nodes from 1,000 kilometers away, and they need to have a high availability, more than 99.99%, and they would like to use some window function, some CETS, such as the grammar in Oracle. So there are not requirements. We will do our best to satisfy them. We need to first look at our architecture of the database. Here we can see there is a meta cluster. The meta cluster stores all the information from the proxy, from the instance, from the agent, from the physical machine, and from some other component. And here is the OS. The OS provides the APIs for the Red Rabbit Manager, and then users can use the Red Rabbit Manager to see how many instances here, what's the status of the instance, and what's the IP and port, and how about the status of the instance. And also we have a schedule manager, and the schedule manager will use the metadata to decide which one is alive and which route is right, or which proxy is right, and how to get rid of a node. And also we have some code backup center, a message center, and here is the LB. If we provide this in private cloud, this LB maybe it's hardware or LVS. When it's in public cloud, it's a component in the public cloud, so we call it VPC gateway. Okay, the first one we want to talk about is security here, the security. Okay, and there are three phases when we talk about the security. The first one is before the SQL come to the engine. We can see the connection here, so we need to encrypt the connection, have some authentication, and when the SQL come to the kernel, we have a kernel level security policy or SQL firewall. Here we can see in the proxy we can configure the SQL firewall, and maybe we have another misoperation prevention here to get rid of some bad happen. And after that we have the audit. Okay, here we can see the audit. First, the user needs to have some audit rows. We can have a regular expression, what SQL we include or not include, what SQL we equal or not equal client IP or execution time or users. And then we combine this row to our instance. And when this audit row happens, what we do to let it go or have a non-message for users, and then we get a audit log and see, so we can check a log and we can have some analyze for the log. Okay, another one is high availability. We've talked about this. Users have more than 99.99% requirement for the availability. Here we can see another number here, 1, 2, 3, or 5, 6, 7. I'm going to talk about what's that mean. Okay, for the one step, the active database is downgraded to the standby. Maybe it's because some bad happened. You can see here we have an active, and every active and standby means a process. This is MySQL or now MariaDB process, and every process have an agent. You know, here the agent gets another information from the process, and we put all the information to the metadata. You know, remember to talk about it. To the metadata cluster, and the schedule load the data, and they know what happened to the master, to the active. So in the first step, the active database is downgraded to the standby. Maybe it's called down or something bad happened, and then in the second step, the standby report is the latest byte log location, and when they report the location, the the schedule node, which one is the latest location, and then the standby merchants can participate in the election, and then we in the fourth step we reconstruct the master and the slave, and we modify the routing rule, and then the request from the proxy can directly to the new node from this one, and to the new node. And the entire switch process is fully automatic without human intervention. And so the strict handover process, we use this to ensure the data consistency. Okay, and another one. You can see this one high availability is happened just in one data center. But if we have more than one data center, so we need to have some other ways to fix that. In this example, we have 3 data centers, 1, 2, 3. And the active and this standby is in data center 1, and this standby is in data center 2. And in this data center, we don't have a standby, but we have a schedule node. We have a meta cluster node here. So when this data center have some network problem, but this data center don't know it, and so this data center don't know what happened in this data center. Maybe it's a network between the 2 data centers interrupt, or all this data center is fail over. So we need to use the schedule with the schedule all across the 3 data center to judge what happened, and we use this to avoid the split brain problem. Okay, if the network between the data center 1 and data center 2 is break, and we know because we have data center 3, so we can't connect to this data center, this schedule, but we have this and this, so we know what happened to data center 1. Then we get rid of this schedule node, and then we can have user data from their client to this data center. But of course, this maybe can't keep the consistency of data, but it can give a high availability. Okay, the fully replication. We will talk about this. Users of, the financial users like fully replication, because they want to keep the data between the standby and the active node is the same, so they can read the standby or read the data from the active node. Maybe that will affect the performance, but they can accept it. But for the full replication, before we did this work, MySQL don't have the fully synchronous replication, but now they have it. They have it in MySQL 5.7, and but still we have some advantages here. We have our asynchronous threads group. In MySQL, with fully synchronous replication, when a source commits a transaction, all replications must also have committed the transaction before the source return to the session that perform the transaction. Fully synchronous replication means failover from source to any replication is possible at any time. But the drawback of fully replication is that there might be a lot of delay to complete a transaction. So we do a little work here. We have a synchronous thread here. That means in this place here in number 1. In MySQL, they just put the date to the Verilog and the data here from the step 2 and to the running log, or apply to the file, and then this thread just here to wait until there is ACK come back to the thread. But here we have a threads group. The thread just send the data to the standby. It's not a semi-synchronous. We just we use this thread to do some other work. But when this come back, when this ACK come back from the standby and the thread gets the ACK, and it will be wake up and to send the data back to the user. So the thread here is always doing the work, but not like MySQL to wait until the ACK come back. So it will always work. This is what we do for the fully replication. We call this a synchronous thread group. Okay. Another one is multi-source synchronize. This is used for our insurance company. We have, a lot of insurance company have some subsidiaries. These subsidiaries maybe use their database is totally different from their head office. Their head office maybe have use MariaDB or MySQL, but the subsidiary use Oracle, MariaDB, Postgres, MySQL, not the database. So they need to compile this data to their head office to do some analyze work. So we use the Verilog extraction, and we pass the Verilog, have the materialize the view log from the Oracle and put all the data to Kafka, and then there are some consumers put the data to MariaDB and or to some other databases. This is what we do for the multi-source synchronize, and then we have for data verification. We to keep the data right. Okay. Another one is DB Brain. We have DB Brain for MariaDB and some other database in private cloud and public cloud. There have monitoring information and before and provision components, and analyze or help user to analyze the database, to analyze the performance and maybe the dialog, and also have some alarm message for users. And also we have some tools for users to fix the problem and have some emergency response components. And also we have a optimization report for users to modify their schema, modify their index, and something like that. And we have more than 70 monitor information, and have 5 graded monitor information, and we have audit. We talked about this before, and we have performance check program and security threat and alarm message, and we help users to queue session and help users to optimize their index, have some expert advice. Okay, user cases. This is a user case from bank. Here in this bank, they have 3 regions. The first one is Shenzhen, another one is Shanghai. Shenzhen is the head office of Tencent. This bank has 3 data center, and the 2 data center is in Shenzhen, and another data center is in Shanghai. They have 1 master and 2 slaves in Shenzhen, but these 2 slaves just in another data center, and they use fully replication here, and also this master have a read-only node, and their clients read the data from the read-only or the master, and the slave here can't read any data from here. But if some field happens, they can switch from the master to the slave. And here we can see in Shanghai it have a synchronous replication between the slave and this master. So use this asynchronous to keep the performance, and we here use the fully replication to keep the consistency of the data. And here we can see Shanghai and Shenzhen, we have a long distance. This means this two node actually is a disaster recovery node. This is what this bank deployment. Okay, thank you.